So let's move on to the next question, guys. In this question, we are given that n is a positive integer. Okay, m is equals to 2, and we have to find the remainder when 3 to the power 4n plus 2 plus m is divided by 10, and we have to compare that with 0. Okay, so now let's do one thing. Firstly, let's break this down. So 3 to the power 4n plus 2, we know the value of m is 2, right? So we can write plus 2 over here. I hope this should be fine. Okay, now what we can write is 3 to the power 4n into 3 to the power 2 plus 2. We broke it down, 4n plus 2. So 3 to the power 4n into 3 to the power 2 and plus 2. This should be fine, right? Okay, now we can write this as 3 to the power 2 to the power 2n. So this is 2 into 2, 4n. So we can write 3 to the power 4n as 3 square to the whole square 2n, right? So 3 to the power 2 whole to the power 2n, because 2 into 2 is 4n. 2 into 2n is 4n. So we can write this as this, right? Into, this is 3 square plus 2, right? Now what is this? 3 square is 9, right? 3 square is 9. So we can write 9 to the power 2n, right? Into 3 square, which is 9, plus 2, right? Now we can add these powers, because 9 to the power of something into 9 to the power of something. So this becomes 9 to the power this plus this. This is 1 basically, right? This is 1. So we can write 9 to the power 2n plus 1 plus 2, right? So this is what we are getting. So basically we have simplified this into this. I hope this should be clear, right? Now tell me one thing. So this is 9 raised to the power of something, 9 to the power of something. What is something? Something is this. So 9 to the power of something plus 2, right? Okay. Now in such kind of questions, what you have to do is that you have to see and match the patterns. So you have to kind of try to understand the patterns, because so what we are getting is 9 to the power of something. So if you see, for example, 9 to the power of 1, right? That is 9. Okay. 9 to the power 2, what is that? That is 81, right? 9 to the power 3, what is that? That is 729. 9 ones are 9, 9 into 72, 729, right? What is 9 to the power 4? 9 to the power 4 is 9 9s are 81 and something, right? Because 9 to the power 4 is this into 9, so 729 into 9, 9 9s are 81, 9 is 18, 26, 7 9 is 64, 65. So it's basically 6561, right? Right? So 9 to the power 4 is 6561. So can you spot some pattern over here? If you look at it closely, the unit digits of all these numbers, it's either 9 or 1. 9 or 1. So this pattern is getting repeated. That means whatever power of 9 you do, you will either get 9 as the rightmost digit, or you will either get 1 as the rightmost digit, right? I hope this should be clear. There is one more observation over here. If this power is odd, if the power is odd, then we get 9. If the power is even, then we get 1. For example, if the power is even, we get 1. The power is even, we get 1. If the power is odd, we get 9. If the power is odd, we get 9, right? That means if we raise 9 to the power of something odd, we will get 9 as the rightmost digit. If we raise 9 to the power of something which is odd, we will get 9 as the rightmost digit or the unit digit, right? Now, if you see over here, 2n plus 1. What is 2n plus 1? 2n plus 1 is an odd number, right? Because we know n is any positive integer, so n can either be positive, odd or even or whatever. So irrespective of what n is, if you multiply 2 into n, that is even, because if you multiply 2 by something, that will always be even. So 2n is always even. And if you add 1 to something, if you add 1 to some even number, it becomes odd, right? For example, if you add 4 and 1, you get 5. If you add 26 plus 1, you get 27, which is odd. So if you add an even number to 1, you will get odd. And 2n is even, so even plus 1 is odd. That means the power of 9 over here is something which is odd. I hope this should be clear. So that means 9 to the power of something odd, right? And we know from here that 9 to the power of something odd will always give 9 as the unit digit, right? For example, in this case. That means this is something, the value of this number will be something in which the unit digit or the rightmost digit will be 9, right? Now, if you add 2 to the number, for example, you get something like 4, 4, 6, 7, 2, 9, right? This is a possibility because we know that the rightmost digit should be 9. I don't care what these digits are. Now, if you add 2 to this number, what will you get? You will get 1 as the rightmost digit, because if you add 2 over here, this will become 11, this will become 3, whatever. So the unit digit or the rightmost digit will become 1 if you add 2 to this. I hope this should be clear, right? So what I mean is that we know that this will result in a number in which the unit digit is 9. Now when you add 2 to it, then one thing is for sure, that the unit digit will become 1, right? So this will be a number of the form A, B, C, D, something, but the last digit will be 1, right? I hope this should be clear, okay? Now, if you divide this number by 10, what will you get? Tell me. For example, if we have 501, the 1 is in the unit digit, right? So if you divide by 10, the remainder will be 1. If you have 1, 2, 3, 6, 7, 1, again, the unit digit is 1. If you divide it by 10, you will get remainder as 1, right? So in this number, if you divide this number by 10, you will get 1 as the remainder, always. So that means the remainder, when this number is divided by 10, the remainder will be 1, okay? And obviously 1 is greater than 0. So the final answer you have is A. So I hope this should be clear, not a difficult question. You just have to understand once and then you'll be able to do it very easily. So what we did was that we firstly converted this number into this number, and then we kind of tried to understand the pattern, okay? And then we know that 2n plus 1 is odd. 2n plus 1 will always be odd. So that means for any power which is odd, we always get 9 as the unit digit. Now if we add 2, we will get 1 as the unit digit. And if we have 1 as the unit digit and we divide by 10, we will get 1 as the remainder. So the answer is A. I hope this should be clear.